Welcome to Offensive Engineering live sessions by InfoSec Relations, where we sit down with security engineers and notable security leaders who work at the sharp end of cloud infrastructure and cybersecurity. Today, we are speaking with Siri Varma Vegiraju, who is a tech lead at Microsoft Azure Security. Siri brings a wealth of hands on experiences across cloud security architecture, identity, and the control plane. He's joining us today independently, sharing his insights as a security leader, and the views he expresses are his own. I'm Samarpita, a volunteer host with Offensive Engineering, and our conversation today is about attacking the cloud control plane. So, Siri, before we get into the questions, please tell us a little bit about yourself and how you ended up working in cloud security.
Thank you, Samarpita, for such an odd intro. Hello, everyone. My name is Siri Varma Vegiraju. I am currently working as a software engineer at Microsoft Cloud Security. And my experience has been on the security side of things for a while. For example, before Microsoft, I worked with Oracle and I worked for their audit logging and security logging side of things. For example, let's say you end up creating a virtual machine on the cloud. So that is an audit log event. Similarly, there is network traffic that is flowing in, and we have to constantly analyze that kind of traffic to basically understand whatever threats are happening on the cloud network. So I was dealing with ingesting such kind of traffic and making sure it is available at a high availability rate for our security researchers so that they can analyze them. So that is what I continue doing here at Microsoft as well, where I end up ingesting a lot of network telemetry information, and I use this information to surface to the researchers where they can go and analyze them. Security space is pretty evolving right now, and I think it is a good place to be in because with the new agentic AI and the shape of cloud security is definitely changing. So that is what has and that is what has been keeping me enthusiastic about about this area and its future.
Yeah, that's great. That sounds very interesting. We'll dive deep into it with few questions. So
Sure.
let's get started. Yeah.
Yep.
The first one would be so cloud services are facing a growing volume of attacks, right? So before we go deep into the control plane, can you please set the scene or what does the current attack landscape against cloud infrastructure actually looks like? And why is the control plane the layer that matters most to attackers?
So from a cloud infrastructure standpoint, there are majorly five or six providers, and most of the workloads are hosted there. So that is most of the other company workloads are hosted there, and that is what becomes the primary target for attackers. Because if they're able to infiltrate one of them, they get huge access to all these company resources or whatever platforms that are deployed on these resources, right? In the last 2 to 3 years, I believe attacks have become cheaper with the rise of large language models and agentic AI. You spend an agent which is an expert and or has expertise on how to carry out a certain kind of attacks or how to carry out a network attack or a cybersecurity attack, right? You spin up that agent and you all these resources that you are able to scan from the infrastructure standpoint, and you can give the agent to go and hey, see what all you find. So that is one major shift we are seeing. And the second one is coming from an identity standpoint. Before it was always flat. For example, there was a tenant, and tenant had bunch of people who had access to these systems. Now things are changing towards agents and sub-agents. So instead of a flat architecture, it is becoming hierarchical because that is one shift that we are seeing. And the second one is passwordless identities are growing tremendously now. 3 to 4 years ago, it was mostly you have private or public keys that are attached to an account, and that is what you would deploy for accessing any of the cloud resources. But one tricky problem with that is you have to keep rotating. Otherwise, once one of the key gets compromised, your whole account gets compromised. So you have to keep rotating, which is a hassle and which is an operational burden. So passwordless identity is also becoming very popular. And the third thing is with the rise of model context protocols, we are just not interacting with simple APIs anymore. These are APIs that give the agents capabilities to access the cloud resources. So the biggest advantage with that is now you don't have to actually understand the complete API itself. You let the MCP, you let your agent come up with the whatever parameters or whatever identities needed, and agent understands the what needs to be done to access that particular cloud API. But the tricky part there is if you're not controlling the access of this MCP API, it can lead to isolation problems where your API might result access to some other resources which they shouldn't have access to. So that is one more thing that needs to be kept in mind. So, in order to summarize, what I would say is passwordless identities, growth of MCP APIs, and the third one is attack identities moving from flat to hierarchical structures. This is one thing that we are actively seeing a shift towards.
Okay. So, when an attacker actually targets a cloud environment, so how
Mhm.
often is the control plane the primary objective versus a secondary target reached through lateral movement? Or what does that split tell us about attackers actually think about the cloud infrastructure?
Yeah, that's a very good question, actually. So, what ends up happening is if you look at a typical breach path, right? These secondary targets are the ones that lead to the control plane. So what I mean by that is, for example, let's say you have a private or public key that is in a GitHub repo, or there is this JWT token that has 7 month, 7 day worth of validation, like it expires after 7 days, or some developer accounts, right? So these accounts have high privileges, and once you are able to get access to these secondary accounts, what ends up happening is I can go and use these accounts to actually query my control plane. For example, let's say I get access to this token for a tenant. Now, what I can do is I can use that, and control plane APIs are publicly available, right? Now I give that token to the control plane, and the control plane lists all the resources that are under this account. For example, let's say a company called Fubar has storage accounts, right? Storage accounts are nothing but your S3 buckets. Now they layered it in different levels. For example, all security buckets lie under one account, and all public accounts lie under one account. With this token, I am able to identify that structure. Once I know that structure, I can do a targeted attack and I can reduce my targets so that I only do a targeted attack on these security buckets so that I can fetch those details. So that is how it has been. So that's why what I have seen is 50 to 60% are on the secondary accounts, and once they get on the secondary account, that is when the other rest of the targets go towards control plane to basically understand where the next step needs to happen. Then from there they move forward. That is the pattern I have seen.
Yeah. Thank you for explaining it so nicely.
Yeah.
Now, please, could you walk us through what a realistic control plane attack path would look like from initial access to full environment compromise? And what are the key steps and what makes each one of those work?
Yeah, definitely. I think the example I'm talking about has happened in the very early stages of cloud. So maybe in 2012s or 13s. This was a very popular attack. So what ended up happening is there are something called webhooks. And what you can do with a webhook is you can, for example, let's say there's a service company A that is offering these webhooks. what these webhooks generally do is you can submit something to the webhook, it'll do the job for you and call your service back. That is how the webhooks work. So there was once this attack where this webhook was deployed on a cloud instance, and the cloud instance has something called identity management service. The IDMS service gives back a security token. The main intention of the IDMS is it sits on every host. And for example, let's say the VM or the service on the VM needs to talk to an S3 bucket or a storage account, any cloud storage account, right? What the service would do is call the IDMS API, get a token, pass the token to storage account, and the storage account would do the validation and and then move forward with the request. What ended up happening was this IDMS, as I was saying, is on the virtual machine, right? You could call it with a local host endpoint, is how it was initially, with a no auth.
Mm.
There was no authentication to talk to that endpoint. The reason was because this is sitting on VM inside a cloud provider platform, it was assumed to be secure. But what ended up happening was an attacker submitted a curl call to the webhook. Now, because the webhook is running on the virtual machine, the curl call was to the local IDMS endpoint, right? Now, the curl call, what they did, whatever curl call the webhook did, it did it to the local IDMS endpoint, got the token, and sent the response back to the destination, or sorry, sent the response back to the source, which is the attacker's place. So with this, what the attacker had was an identity token, a JSON web token, basically. With that token, what they ended up doing was they called one of the storage buckets APIs to actually see what all resources are there. This is a combination of attacks, a combination of security missteps, is what I would say. So one, the webhook was able to call the local host. There must have some restriction there. Second, the access control privilege that was given to this token was very high. They could go and list all the buckets, list all the objects of the buckets, and list the data as well, right? So this is the security mistake, very broad access control. With that token, what it was able to list all the data and do a data exfiltration. So this is what ended up happening. In this case, basically, the control plane was indirectly involved, but it was not a direct attack on the control plane. It was by getting the token and the combination of network security missteps plus broader access level that led the data to be exfiltrated from storage buckets. This can be an example of an attack, actually.
Yeah. Yeah, it's really nice explanation. Thank you. Moving on to our next question then. So the management API layer is where most control plane activity happens, right? And also where
Yeah.
defenders tend to have the least visibility. So how do attackers then abuse cloud management APIs once they have a foothold? And what does malicious API activity look like versus legitimate activity that are in practice?
Yeah. So when it comes to a malicious API activity, right, the first thing that you would end up seeing is, for example, let's say all of these management APIs. Today, cloud providers offer a lot of gateways, and gateways are where you expose your APIs through, and what you would see is that is where most of the controls are there. For example, authentication, authorization, throttling. All of this happens at the management, the gateways, at the gateway level, basically. So in a typical attack, what ends up happening is you see a traffic spike. The reason being a variety of attacks are being targeted to your management layer to understand what all risks are there. So, for example, you might be using a very old dependency in your API. which might have a particular CVSS or a CVE.
Linking to that, I have another question. So, managed identities, service principals, and non human identities, they have become like a dominant attack surface in cloud
Mhm.
environments, right? So, how do managed identities work, and how are they supposed to secure cloud access, and where does the model break down in practice?
I think more of cloud providers are switching towards these kind of identities. If I have to take a step back, what are managed identities and substance, right? So
Mhm.
first there were passwords, there were human accounts, then there was a need for services to communicate with each other. That is when service principles came in. Then there came in managed identities because both the service principles and the version before that had one common problem. That is the keys. The keys need to be managed manually. For example, let's say there is this private key attached to the service principal and that got compromised. Now, if I had to do the rotation, for example, if I am a service provider, I'm hosted on this, I might not have the expertise to carry out that in a short span of time. That is a, because once your API or your service principal is compromised, your clock starts ticking. The reason being, the attacker now has access to these keys and he can anytime start abusing these keys to either access your APIs or exfiltrate data. Now, how cloud providers solve this is using managed identities. The benefit with managed identities is all of the key management is controlled by the cloud provider itself. So they take care of rotating the keys, creating new keys, and everything. So now I, as a service operating on the cloud, don't have to worry about that. And because they are constantly rotated, my identities are pretty secure. That is the biggest advantage with managed identities. However, one problem still persists: access controls. The access control still lies with me because I am the one that is telling, hey, if for this managed entity, what all can it do? Can it delete a bucket? Can it delete a VM? Can it delete a block storage account? These all things are still controlled by me. So there is some due diligence required by the users or the service practitioners to make sure each of these managed identities have as restrictive permissions as possible. And the way to secure that would be, in most of the cases, your managed entities would just need read or write. So, for example, let's say I'm talking to another API, right? You would most probably not be doing, for example, in case of creating a VM or deleting a VM, it is most rare that you would end up carrying out a destructive operation. So, in most of the cases, it might be updating or creating some things. So, that is where I would say restrict or reduce the amount of scope that your managed entity can do. And one more thing is isolation is very important. If you have a managed identity for creating VMs, don't use the managed identity for creating storage accounts or block storage accounts as well. Isolate them so that even if one in case gets compromised, the others are not affected. And the same thing comes to multi-region as well. Your identities should be regionally isolated so that even if one identity is exposed, it only that particular region is exposed and not the other regions. So these are some of the things I would say. To summarize, actually managed identities are the best practices, is the best practice to currently use when managing, when talking to other services. The only thing that I, as a service practitioner, needs to take care of it is the scope of what the managed identity can do needs to be reduced and given as minimum as possible. Basically, least privileges.
Okay. Siri, now that you have so beautifully explained this, my next question would be this then. So, agentic AI is changing how identities are being used across cloud environments. So, what shifts are you personally seeing in how identity is managed and the new risks that goes with agentic AI that introduces the existing identity security model that it wasn't designed for?
So with the agentic AI, what ends up happening is you have more of hierarchical structures than a flat one. The meaning for that is today there is one orchestrator agent and there are sub agents. And the orchestrator agent is the one that tells sub agents what to do. For example, let's say I need to, what can be a very good example? Let's say I need to order some food, right? Let's say I have to order some.
Mm.
The orchestrator agent knows how to order the food, but it involves looking at the menu, then selecting the food, and then doing the payment, right? Now, what we are seeing is each of them have their own sub agents that are experts in that and doing that work. So,
Mm.
what would end up happening is for these tools, agent tools, the security needs to be drilled down to that particular level. And the way to do that would be, for example, for the agent that is viewing at the menu, it should not have permissions for any payment related activity. So that is how the trickling down should happen. So for example, again, I think this is where least privileges again comes into picture. So for each of the sub agents, they should be restricted to what they can perform. So there are multiple ways to do this. One, you control at the API layer. For example, let's say your sub-agent is the one that makes calls to either view a menu or do a payment activity, right? So there is something sandboxing that happens. And what that sandboxing architecture basically says is, hey, these are all the list of APIs that you have access to, and these are the lists that you don't have access to. That is one way to control it. And coming to an identity standpoint, again, this is where I was saying, for example, each of the subagent should get its own managed identity. And you're also able to control what the subagent is can do because of what the managed identity has access to. So I think this is where managed identities definitely help. And basically, they'll end up controlling what your agent can do and cannot do.
Yeah. What then are the blind spots you consistently see on the defensive side when organizations assess their control plane exposures? So, where do security teams tend to assume coverage that they do not actually have?
So one thing I've seen broadly is control control plane APIs. There are a bunch of APIs like simple CRUD, create, read, update, delete. Apart from
Yeah.
these, there are additional APIs as well. Some these APIs are somehow these are APIs sometimes have admin access. For example, let's say in order to quickly solve a problem, what the team has done is they have created an admin API which has administrative privileges to what the control plane can do.
Mhm.
Now, when they expose it through the management API layer, what ends up happening is only the cloud operations are exposed. But unintentionally or intentionally, sometimes the admin APIs are also somehow get exposed. And the main problem there is something called proliferation, where you end up spinning a bunch of these APIs and you forget about them because you don't have a central place where you know what all APIs are available, right? So that is one problem I have definitely seen. And once you forget about them, these are publicly accessible, but just not documented or listed to the outside users. So in case of an agent, it can, with the capabilities an agent has, it can quickly identify these admin capabilities and actually compromise your security. your control plane security. So that is why it is very important, at least now, that you document what all APIs are available, either for your control plane or data plane, and make sure these are required. And if not required, you go ahead and remove them. That is one blind spot. So to summarize, I would say API proliferation. The other thing I think we have been already discussing, that every organization control should follow the least privilege or least restrictive action to their APIs. So only give access to whatever is needed, and don't provide an overprivileged account which can do anything across all your APIs. And the third thing I would say is regional isolation is very important. What I've also seen is one API can access data from another region. So, for example, let's say the control plane is deployed in region one, and there are two control planes. Region A has its own control plane. Region B has its own control plane. But region A control plane can have permissions to access to region B. So you're breaking the isolation part there. So, so it is very important to actually have that isolation. Otherwise, whenever there's a compromise, it becomes very hard to contain the attack and basically stop it. That is what I.
Yeah. Okay. Let's say, given the scenario, when a control plane access is compromised in an infrastructure that actually supports like government services or critical national systems, right? So, how do you think about the line between a security incident there and something with much broader implications? Does that framing change how you respond?
One thing I would say is it is highly dependent upon the type of system you're interacting with. For example, let's say you are using OAuth, right? OAuth itself is a service provider. Now, the OAuth is used by multiple other services. For example, your emergency services, your 911 services, fire ability services might end up using that. If the OAuth invest in the core infrastructure that governs your identities across all this gets compromised, then that is definitely a sovereignty problem. However, if a particular, for example, maybe a restaurant API or something gets compromised, then that is not, right? So it would highly depend upon the type of server, type of infrastructure that is getting affected. And I don't think that framing changes how you respond. Basically, whatever controls we talked previously stay the same. Either you are operating an emergency service, or you're operating as simple as a inventory service. In any of the cases, the three security fundamentals, what I call network isolation, least privileges, and then API proliferation, stay. Every service provider needs to make sure these are properly covered so that they offer the best customer service for their customers.
Yeah. Thank you. You have explained this beautifully. So, I just have one last question for you, and that's for all people who are more enthusiastic about building a career in cloud security today. What is that one area that you would tell them to focus on that most people in the field underestimate?
So I would say there are two aspects to it, right? One, you either become a core security researcher, or you're on the engineering side of things. So if you're very interested in security, you're interested in identifying vulnerabilities, pen testing, these things, this is a completely different domain. So what the most important thing there is, you would have to stay very curious on how things are working. For example, there's let's for example, Microsoft itself has their own security wing, and there what they are constantly looking for is identifying vulnerabilities in their existing infrastructure itself. So what they end up doing is they do constant there are things they do constantly ping APIs, or they try to perform different kinds of attacks and basically see if they can compromise the infrastructure. That is one kind of system. The second kind of system is, now in order for them to perform that, they would need some data. Now, in order to gather the data, this might be first you have to have a source, and then you have also have to collect that so that you can present them. This is the engineering aspect of it. So for the engineering aspect of it, it would be more like, hey, a security researcher coming to you and telling, hey, I need this data. And then you would go and figure out, okay, I can get this network data from a VM, and I can surface that through different data pipelines to the security researcher. So this is the engineering problem you're solving. So you really have to understand which part you like, and the only way for that would be you go ahead and do things. For example, there are a bunch of vulnerabilities available outside. Like there's a CVE database. Pick one CVE and see if you can basically replicate that. Once you're able to, and then do it for three, four things and see if that interests you. If that is definitely something you like, then I would say start doing some open source contributions. For example, why don't you try? There are these bug bounty programs that Facebook, that Meta, Google, and all these offer, and try joining those programs and see if you can identify any vulnerabilities. Right? Then you will know, oh, if something you're interested, then go ahead with that. Otherwise, the plain software engineering path is where researcher, the engineering side of the problem comes up with. And if you're already a software engineer, then you can just switch to an internal org that does security and see if that interests you, right? So these are the two things I would say. And the only way you would know if you would like this is you try them out.
Yeah. Okay, that's perfect. So thank you so much, Siri. This has been genuinely a useful conversation, and personally, I have thoroughly enjoyed it. And that's exactly what offensive engineering stands for. So thank you to everyone who listened to this session. If you enjoyed it, please subscribe to Offensive Engineering, and all the important links are in the description. And we hope to do another session with Siri soon on the attacking the cloud data plane. So thank you so much.
Thanks a lot, Samarpita, for taking the time to interview me. It was great talking to you folks.